Have you ever wondered if simulating life is actually possible while coding in Python? That's exactly what I'm going to be answering. In this video, I'm going to be building a zero-player game called Convoy's Game of Life. So Conway's Game of Life is a famous computer simulation made by the mathematician John Conway in the 1970s. But the truth is that it is not a game. All you need to do is set the initial state of the cells and the rules of the game can take over, which we'll cover later in the video. From those rules, you get weird pattern. Some stay still, some repeat forever, and some even move across the grid. So the rules are simple. A cell with 2 or more alive neighbors survives. A cell with more than 3 die due to overpopulation. And the third rule is that a cell with less than 2 alive cells dies due to underpopulation. And the last rule is that a dead cell with exactly 3 cells becomes alive. These are the only 4 steps for the simulation. Okay, so let's hop into a text editor. So for this, I'm using PyCharm, but you can use any text editor you want. So let's go ahead and create a new project. So I'm going to be calling this simulation of life. And you see this is one mistake that most beginners make. You're not supposed to have spaces in your folder, so make sure you add underscores or dashes instead. So don't get a Git repository for most cases and select the Python version. In this case I'm using the latest version, which is Python 3.13. so go ahead and click create, and I'll just do this window for now. Okay, so now the folder is all set up. So I'm going to go ahead and create a new Python file, and I'm just going to call this main. There you go, it created a new file for me called main.py. I'm going to go ahead and start by initializing and importing all the libraries we will need. So in this case we only need 2. So I'm going to go ahead and click import sys, which is system sys, and then I'm also going to go ahead and import pygame, and that's all you need. So if you're in a text editor, it's going to say there's no module named pygame, so don't worry, just go ahead and go to your terminal and just go and type pip install pygame. This will go ahead and install pygame for you. Okay, so that's it, and then I'm gonna go ahead and initialize pygame using pygame.init. So I'm going to go ahead and start initializing all the basic parameters that I will need for the creating of the window. So we're gonna have width and height, set them both to be equal, and then also do rows and columns. So in this case you can choose any number for either of these, but in this case I'm just going to choose 30. And if you want your screen to look good, make sure that this number is directly divisible with this number. It's going to make it look a lot better. And then I'm going to go ahead and do cell underscore size, which is just going to be how big each cell space is going to be. I'm going to go ahead and calculate this, as I really do not want to set it manually. So I'm going to do width divided by the columns. So in this case I'm making sure that the 2 numbers that I'm entering over here and the 2 numbers that I'm entering over here for the width height also equal, and rows and columns is also equal. So make sure you do that, and in this case it will make a square, so which is perfect for us. So now I'm going to start declaring some variables for the colors that we'll need. So we'll have a color called alive color, which is basically just gonna be the color which we're gonna use to represent if the cell is alive or not. So in this case I'm using red because why not. So this is an RGB value. If you don't know what an RGB is, it's red, green and blue, and each value is arranged from 0 to 255. So this is going to be the brightest red that we can show over here. Then we're going to have a dead color, which is just going to be the color of the cell when it's completely dead. So I'm just going to keep this as black, which is 0, 0, 0. And then we're going to have the grid color, which we'll use to mark like the grid so it's easier for us to see. So I'm just going to do 40, 40, 40, which is going to give like a gray color. It's not too dark, it's not too light, it's just perfect. You can go ahead and experiment with these values, whichever color you want. And then I'm going to go ahead and create a variable called screen, which is just gonna initialize the screen. It's pretty basic. Then I'm gonna go ahead and create a variable called clock, and that's just gonna be pygame.time.clock. We're gonna use this later on, so make sure you don't forget this. And then I'm just gonna create the basic loop. So right now, if we just run this code, nothing is gonna happen because we're not actually running anything. We're just initializing everything. So we're gonna go ahead and start creating some stuff. So go ahead and create a variable called running and set it to true, and then just write a while loop while running. So while it is true, we're gonna do pygame.display.update. So this will make sure that the window that we create keeps on running and keeps on popping up. So as you can see, it is running as there is a window over here, but there's nothing to show in the window, so it's just not going to show anything right now. And the only way to stop the code right now is by stopping the code manually. If you want to make sure that you stop the code, you can just do for event in pygame.event.get, and then if event type is equal to pygame.quit, we're gonna set running to false. It's gonna make it exit this loop. Once it exits the loop, this is only gonna happen once we want to stop the code. I'm gonna do pygame.quit to close the window and sys.exit to stop running the Python file. This should be good for now. And then if I run this, there you go, it's over here, and I can go ahead and click on this X button. It's gonna go ahead and stop, and the code also stops, so I don't have to like close it over here. Okay, so I'm gonna go ahead and run this again. So as you can see, it's just a blank screen right now. So I want to make sure that we have some grid over here, so it's easy for us to see. So I'm go ahead and let's define a function. So you do that with def. I'm just gonna call it draw grid. It's not gonna take in any parameters. So I'm gonna create two for loops. So for row in range rows, and then another nested for loop for column in range columns. So this is just gonna find like in each row it's gonna get each column. So for that I'm gonna create a new rectangle. So I'm gonna call it rect, and then I'm just gonna do rect is equal to pygame.rect. Make sure that the R is capital, and then I'm just gonna do column and then into, which is asterisk, cell size, comma row, into cell is equal to size, comma cell size, comma cell size. So this is gonna create a rectangle for us. Now if we go ahead and call this function over here and do draw grid and run it, you'll see you don't see anything over here. That's because over here we are just creating it as a variable. We actually need to draw it onto the screen. So for that you need to do pygame.draw.rect, and then you need to pass the screen, the color, and then what you want to draw. So now you can go ahead and run the code, and it just created this, which is not what we want. That's because we haven't defined the width yet. So I'm gonna go ahead and do comma 1. It's gonna define the width. Go ahead and run it, and boom, see, perfect straight lines. Also now you can see, because I set the rows and columns to 30 while the width is 800, there's some extra values that are left over here. So that's why I told you guys to make sure that it is completely divisible. So 800 is not divisible by 30. So I'm gonna go ahead and change both of these to 40. Rerun the code, and boom, perfect. Okay, so now we're gonna go ahead and start with the next part now. Okay, so now I'm gonna go ahead and create another color, which is going to be the background color. So I'm just going to call it bg underscore color. Now I'm just going to set this to black, because who doesn't like black, man? Black and red just looks good. Okay, there you go. So I'm going to come over here and do screen.fill, which is gonna fill the whole screen with this color. So if I go ahead and run this, it's black. So now if I want to go ahead and change this to blue, I can just go like boom, now the whole background is blue. It does look weird, so yeah. So I'm gonna go ahead and change this to black. And then now we're gonna come up with the next major part, and that's gonna be creating a class called cell. So I'm gonna go ahead and create it over here. So now this class is gonna store the row, the column, the state, and the color of each of the cell on the screen that you can see. And it's also gonna allow us to have functions specifically for that cell, like drawing it, setting its state, and also getting its neighbors, which we'll need later in the code.
Okay, so go ahead and make a class.
Okay, so now each class needs to have an init function. So I'm gonna go def underscore init underscore. Now you always need to pass self, but I'm also gonna pass the row and the column. So using each row and the column, you can uniquely identify each cell, because you can't have two cells in each row and a column. So now I'm gonna set self.row is equal to the row that we from here, and then also self.column also is equal to the column that we set over here. And then I'm also going to give it two more attributes, which is still its state. So is it alive or not? I'm just going to set it for false at default. And then also self dot color is equal to dead color for now. So normally each cell is going to be dead once we create it. Then I'm going to go ahead and create a function called draw, which is only going to have the self and the screen where you want to draw it. Each of this cell is just going to be a rectangle or a square. So I'm going to do rect is equal to pygame dot rect, again r needs to be capital, self dot column, self dot row, cell size comma cell size. But now there's a mistake. So now this will just create it at the location, but we are not giving it how big we want it to be. So I'm just going to do into cell size, and then same with the row. That's gonna go ahead and create it for us. Then we're gonna go ahead and have to draw this on the surface. So I'm gonna do pygame dot draw dot rect, and then I'm gonna do screen where I want to draw it, the color, so self dot color, so it can either be dead or alive, and then what we want to draw, which is the rectangle in this case. And then I'm gonna go ahead and create the grid border again to make sure it's on top or overlapping. So pygame dot draw dot rect screen comma grid color comma rect, and then the width needs to be 1 like we did before. Go ahead and indent this in over here. Yeah, and that's good for now. I'm gonna go ahead and create two more functions. So one is gonna be called set alive. Oh my god, set alive, which is just gonna need self and then whether you want to set it alive or not, and then alive is going to be a bool, so true or false values only. And then I'm just going to do self.alive is equal to alive, so either true or false. And then I'm also going to set the color to make sure it changes, and then alive color. This is going to be an if condition over here. So if alive is equal to true, basically, then it's going to be a live color, else it's going to be the dead color. Okay, so that's one of the functions. And then this is the next function called get underscore neighbors. So this function is going to be used to get all the 8 neighbors around each cell, which will allow us to check for the rules of this game. So I'm going to need the self, and then I'm going to need the grid, and then grid we haven't defined yet. So let's make a new variable called grid, which is going to be a list, and then we're going to go through cell and then r comma c for c in range calls, and then for r in range rows. So this is gonna go ahead and create each cell. We're gonna go ahead and store it in a list called the grid. In the function get neighbors, I'm gonna go ahead and create a list which is going to be an empty list called neighbors, and then for displacement r in, and then -1 comma 0 comma 1 in every neighbor for us. Then I'm gonna append this row, and then I'm gonna go ahead and append this row and column into the neighbors list that we just created. So using append grid and then r comma c, which is the row and the column of that particular cell, and then that's it. So then I'm gonna go ahead, exit, and just gonna return the list that we created called neighbors. So that's it for this. And now see, now I'm getting an error over here because I'm trying to initialize this before I've actually defined the class called rows. So I'm go ahead and neighbor for us. Then I'm gonna go ahead and append this row and column into the neighbors list that we just created. So using append grid and then r comma c, which is the row and the column of that particular cell, and then that's it. So then I'm gonna go ahead, exit, and just gonna return the list that we created called neighbors. So that's it for this. And now see, now I'm getting an error over here because I'm trying to initialize this before I've actually defined the class called rows. So I'm go ahead and going to copy this, and I'm gonna put it after this over here. So that should be fine. So if I run this, nothing is gonna happen right now. So for that, we're gonna use the mouse to toggle the state of each cell, so dead or alive. So go ahead and come over here and do if pygame dot mouse dot get underscore pressed. It's gonna go ahead and see if we have done a left click, and if we have, we're gonna get the X and the Y of the mouse, which we're gonna use to get the row and the column by dividing it by the cell size, so you can precisely figure it out. Then we're gonna do grid and then the row column, and then we're gonna set it alive once we do click it. So every time we do a left click, we're gonna set it to alive. And then just so we can see, I'm gonna do grid, then I'm gonna go ahead and print this. So row column dot get underscore neighbors, and then I'm gonna pass the grid. So this is the cell, so the self argument that we're gonna need over here, and then the grid, which is the grid over here. Okay, so as you can see over here, nothing is happening. So now that's actually because we'll have to change this draw grid function over here, because we have actually implemented most of this over here. So go ahead and remove all this. We'll start from scratch. and we'll do for row in a grid, and then we're gonna do for cell in row, because at that point you just have the cell. We're just going to do cell.draw screen. So that's going to go ahead, draw the cell and the border, the grid border around it. Go ahead and run this. Boom. So it did set it alive. It's just that this is not the particular cell that we wanted to active, as our mouse is over here, not all the way over there. And then that's because over here I actually made a mistake while writing this code. So the X is actually the column. So this is supposed to be X and this is supposed to be Y. Supposed to be the other way around. So now if we go ahead and run this, boom, we can set it exactly where we want it.
So not the quite output that we wanted.
Okay, so now let's go ahead and debug this. So I'll try and see why this is happening.
A few moments later.
Okay, already found the error. Okay, so over here it's registering each click multiple times. I only clicked it once and it's printed high so many times. That's not what we want. So we're gonna come over here, define a new variable called FPS. I'm just gonna set it to 60. If you set it higher, the game is gonna run a lot faster, gonna cause you troubles. Don't do that. And then I'm actually gonna do clock.tick FPS. So it's gonna make sure that it only runs 60 times per second and doesn't just keep on running it over and over again. But that problem still happens even after I run the code. So time to get debugging.
10 seconds later.
Okay, so I found the mistake over here. So this is actually supposed to, the whole thing is supposed to be indented in this for loop to make sure it only runs once every event, to make each cell dead in case you like misclick or something. So go ahead and do, we can just do elif because you can't click both at the same time. Pygame.mouse.press2. So 0 is left, 1 is middle, 2 is right. So keep that in mind for later. And then again we're gonna get the X and the Y. You can just copy it from here. The row, everything is just gonna be the same from here. We're just gonna set the alive to false though, and not alive because we're making it dead. Go ahead and rerun. Boom, alive, dead, alive, dead, alive, dead, alive, dead, alive, dead, alive, dead. There you go. You can have fun around with it. You can draw now, I guess. So even though this is not what the project was for, you have created your own pixelated sketchboard. So that's it for now. Let's go ahead and move on to the next part, which is going to be implementing the rules and updating this window, which is going to take some time. So buckle up and I'm going to see you in the next chapter. So in this chapter, I'm going to be creating a new function called update, which is going to help us implement the rules. We're going to also change most of this and add a lot more. So get ready. So I'm just going to go ahead and create an empty function called update for now, which is not going to have anything right now. It's just going to be empty. This is just for placeholder right now. We're going to change it later. And then next comes the other main part, which is the playing. So go ahead and create a variable called playing, which is either going to be set to true or false. So when you want to run the simulation, you're going to run it as true. When you want to pause the simulation, you're going to run it as false. Simple as that. Then we're going to go and create some if conditions over here. So if playing, so if it's true, we're gonna update the grid. Using that, we're gonna do something that we haven't done before, which is going to be pygame.display.setCaption. No, not update, my bad. Set caption, and then I'm gonna set the caption to be playing live. You can set it to whatever. So a caption is basically what appears over here. So right now it's playing live because right now it's true. So this is what is going to be over here. If I set it to help, run this, it's gonna be display help. So like that. So let's go ahead and change this back. But if it's not playing, we'll want to set the display to not game over but life is paused. Okay, so that's a simple way to know without introducing any UI elements whether the game is playing or not just from the caption, because I don't want to create any extra buttons over here. So now to toggle the state to see whether we want to play or pause it, I'm going to go ahead and do another if condition over here, which is going to be if event.type is equal to key down. So if we press a key, and then if the key is, so the event.key is equal to pygame dot, so the capital K means key. So now you can go ahead and click any key, set any key. So it can be A, K, F1, F2. So I'm gonna go ahead and set it to K, which is lowercase. So every time I press the play button, I'm gonna set it to either play or not playing. So go ahead and set it. So I'm going to do playing is equal to not playing. So as playing as a boolean, the not basically like switches. So if it's true, it's going to set it to false. If it's false, it's going to set it to true. Basically quite the opposite of what the value is right now. So that's perfect for now. So if we go ahead and run this, so right now it's playing. If I press K, it changed to pause. Okay, so moving on to the next important part, which is finishing this update function. So go ahead and remove this. So in the update function, we're gonna have a list called new underscore states, which is just gonna store the state of each cell for the next update, because if we place it on the current one, it's gonna mess things up and the logic. So we're gonna create a new list for that. So we're gonna set it to false for every single cell. Okay, then we're gonna go ahead and create a new for loop, and we're gonna go through each row in range of rows, and then for each column in the range of columns, and then we're gonna get the cell which is located at that particular row and column, and then at that cell we're going to get all of its neighbors using the get cell function that we defined before. And then we're going to also have another variable called alive neighbors, and then alive neighbor is going to be the sum, and then for each value that is 2 we're going to set 1, and then for n in neighbors, if n dot alive. So this line over here is going to add 1 to alive neighbors for every neighbor that is alive. So that's basically what this line does. And then using this, we can create all the rules of this game. So if cell is alive, there are multiple rules. So the first one is if there are less alive neighbors than 2, we're gonna set the new state is gonna be false, because it dies due to underpopulation. And then the second rule is for keeping them alive. So we're going to do an elif if alive underscore neighbors, only if I could spell, is in the list 2 or 3. This is just a fancier and faster way of writing if it is 2 or 3. Then we're just gonna set them to true, because we want them to live on for the next one. Then we're gonna have another elif, and then it's gonna be if alive underscore neighbors is greater than 3, so they die due to overpopulation, so new state will be false. Then we're gonna also have then come out that indent and do else, because that was just if the cell is alive, but if a cell is dead we can also revive it. So if its alive neighbors is equal to 3, then they become alive. So that's it for the code. So then we can go down here and run the code. Okay, so now we're getting an error. List index out of range, so let's go ahead and fix that.
2 minutes later.
So the problem over here is that if there's a cell that is in one of the borders, the row next to it does not exist, so we'll have to change that, and instead of this we can only do this. So if I is greater than or equal to 0 and less than self.row, then only we'll do this, and same for the column. So we go ahead and run this again. Boom, it works. So we can go ahead and create whatever pattern we want. So let's go ahead and do this. Click K to start running. Okay, so it's not running because it's not really changing. So let me go ahead and debug again.
1 eternity later.
So I made a mistake over here. It's not supposed to be self.row, it's just supposed to be row. So that's a mistake. Calls and rows. We go ahead and rerun this. Don't play. Okay, and start running. It is running, but it's not updating. So let me go ahead and fix that too.
2 minutes later.
I've completely forgot to actually use this list over here to update all the cells. So let's go ahead and do that. So for row in range rows, and then for column in range calls, we're gonna do grid row column dot set alive, and then over in the parentheses we're gonna have next underscore states, which is our next stage, which is our list over here, which has everything. And then we're gonna pass the row and the column to get that particular element, and we're gonna go ahead and close that. Oh my god, it's not called next stage, it's called new stage, so that's my mistake. Go ahead and run this code. So we run this. Oh, there you go, it works. So you can create some cool patterns with this. Like, let's go ahead and draw some random stuff over here and run this. There you go, that's simulation of life in Python. I hope you guys had fun. Please leave a like and subscribe if you like it, and thank you very much. Okay, so a quick side note, I was actually going through about this and I found out there's a whole Wikipedia page on it, so you can create some interesting so I found out you can create some interesting things with this. So like this, I think is called a glider, which moves diagonally across the screen. And then so this is the Wikipedia page. So as you can see, people have came up with people have found out. So this is the Wikipedia page. So as you can see, people have found out a lot about this. So there's like glider guns, you can even like simulate stuff over here, you can read about its origin, and this is an interesting area over here. So these are example of patterns, so you can recreate this in our code over here, it'll work perfectly. And like, so this is the glider that I just showed you guys, but there are a lot more that you guys can do. There's also about, you can also learn more about the algorithms and the variations of this game. So go ahead and check this out. I'll go ahead and leave a link of this in the description below, so make sure to check it out.